Hello everyone, here is the proposal presentation for NTU AI6127, Deep Neural Networks for Natural Language Processing. Our project title is an Albert-based conversational question answering system. We have three team member, Bai Wen, Gao Kekuan and Guan Xin. Before the presentation you may note that, as the master student major in artificial intelligence, we should utilize all possible resources to enhance our learning and engineering experience. Thus, in this presentation, the audio is performed by me, the Google Cloud Text-to-Speech API. Please refer the following link for the details. Contents of this presentation. Our proposal contains 6 parts: project goals, NLP tasks, data and processing, neural model, baselines and evaluation. Project goals. Conversational question answering, named CQA, is a QA task involving comprehension of both passage and historical QAs. It is proposed to mimic the way humans seek information in conversations. Albert, which is a recently released model for the self-supervised learning of language representation, uses parameter reduction techniques to lower memory consumption and increase the training speed of BERT. Albert scales much better compared to the original BERT and can improve the performance of the downstream tasks. The reason we choose these two as our research targets is that both Coca and Albert are newly released in the NLP. Combining them together might help address the conversational question answering challenge, which is more close to nature of human conversation. Our primary goal is trying to implement the Albert model with experimental adjustments on the Coca to address the conversational question answering challenge. It would be better if we can take a place on the leaderboard of the Coca. Our secondary goal is trying to wrap this project into an integrated online conversational question answering systems which can be accessed by public NLP tasks. We intend to build a conversational question answering system based on our model. It is essential to enable machines to answer conversational questions just like humans do in the real world. Our task is to answer a series of questions by giving a document and a conversation. Every question after the first one is dependent on the conversation history. The input of the system will be a document with a series of questions in a conversational context. The output will be the answers, which are free-form text to the questions, and the system also is able to determine if there is an answer to the question given the conversation and the document. Data and processing. The main datasets we will use is the Coca dataset and QUAC dataset. Coca is a dataset from Stanford which aims to measure the ability of machines to understand a text passage and answer a series of interconnected questions that appear in a conversation. While questions in QUAC are often more open-ended, unanswerable, or only meaningful within the dialogue context. We need to pre-process the data in the following aspects: tokenization, embedding, and classification. We may use GLOVE or fast text to represent the words in the dataset. Then we will classify the dataset into 3 parts: training, evaluation, and testing. We are considering using SPACY or NLTK to handle these works. Neural models. We plan to use the Albert model, which will be downloaded from the internet to deal with conventional question answering problems. We will fine-tune the model for Coca dataset and may add some neural network layers, such as BiDAF, CNN, LSTM, etc., to try to improve the performance. The output layer on top of Albert will be a classifier for different types of the answer in a dialogue, free of text answer of yes, or no, or unknown. Then we will try to use some methods that can have a significant effect on other tasks to verify whether it can help us on our task. Baseline. As we are trying to add experimental adjustments on the Albert, the baseline model we will use is the vanilla Albert model, which will be downloaded from the open source community for the Squad 2.0 dataset. Then use it as a pre-trained model in the downstream task by fine-tuning or feature ensemble. Meanwhile, we will compare our model with baseline models. such as Roberta Plus at Plus KD model, TRMT model, and Google Squad 2.0 plus MMFT model, etc., which were also implemented to address the conversational question answering challenge. Evaluation. COCA usually uses macro average F1 score of word overlap as its evaluation metric to measure the performance of different solutions. Please refer to the following formula. Currently, there is no application of Albert on the leaderboard of COCA. In order to compare with the existing published work on COCA dataset, we will use the same evaluation metric. As a new solution optimized from BERT, we expect Albert can outperform BERT's performance and learn more about enabling natural human-machine communication. That's all for the proposal presentation. If you have any questions, please contact the authors. Thanks for your watching and listening.